Hi friends, welcome to Wiki Lectures. In this lecture, we are going to discuss the next 5 questions that we have posted in our Telegram channel from Karnataka SET 2020. Rigid body consisting of three particles A, B and C is constrained such that A and B are rigidly fixed to be at rest. Which of the following statement correctly describes the behavior of C? Actually, behavior of C means path followed. Okay. So on your right side here, A and B is fixed and C is able to move. Now, first of all, we want to know what is mean by a rigid body. Rigid body is such that all the particles A, B and C, their distance will not change, are fixed. A, B, the distance is fixed, and C to B fixed, and this CA is also fixed. This do not change. And what we can change is its orientation we can change, but here in this case, since A and B are fixed, the orientation of A and B should not change, or it is at fixed position. In that case, what is the behavior of C? C can move in a surface of sphere. No, what is the movement of C can have? It cannot move here. It can move only we can rotate this, right? When you rotate, the C will follow this path, a circular path. So C can move in the circumference of a circle of constant radius with the line joining AB passing normally through the center. See, line joining AB is passing normally through the center. This is the correct option. Here we have a straightforward question. If a motion of the planet of mass m around the sun with the mass capital M is treated as a two-body problem, then if the t is the time period of revolution and a is the semi-major axis and g the gravitation constant, then exact form of the third law of Kepler. The answer is t square by a cube equal to 4 pi square by g into m plus m. And here with if you have pi square here, this is the simplified form. Okay, this is the simplified form, and option C is the when you are considering the two-body problem. The eigenfrequencies of small oscillation of a system having Lagrangian m by 2 into x dot square plus y dot square minus m by 2 into omega 1 square x square omega 2 square y square. So this is oscillation in 2 dimension. So let us write what is Lagrangian L my Lagrangian. This first term is nothing but the kinetic energy term. The second term is potential energy term. So m by 2, if you take it out, and this is what is that kinetic energy. This is x dot y dot y dot. In that case, this x dot square, so x dot, so this is x dot square, and there is no x dot y dot term, so this is 0. Similarly, x dot y dot term is 0, and y dot square, that is 1. So this is the equivalent matrix for kinetic energy term. Similarly, we can write it for potential energy term. So m by 2 omega 1, so this is x y y. So here you have 1, again here 0, 0, 1. Now determinant of v minus omega square t is equal to 0. This will give you eigenfrequencies of the system. V minus omega square t, determinant of v minus omega square t. Now here this is your v, this is your t. So v minus, so omega square, sorry, here what we left is omega 1 square, this is omega 1 square, this is omega 2 squared. Okay, so omega 1 squared minus omega square t, omega square t is nothing but here you have only 1. So the second quantity, entry is 0, third entry is again 0, and third one omega 2 square minus omega square, m by 2 outside. Right, now determinant equal to 0 means omega 1 square minus omega square into omega 2 square minus omega square must be equal to 0, which means either this should be equal to 0 or this should be equal to 0. So let us take the first one equal to 0. So the solution will be omega square equal to omega 1 square, which means omega equal to, that means omega x equal to omega 1, omega square along y is equal to omega 2 square equal to omega y is equal to omega 2. So this is it. So what is the answer? Omega x equal to omega 1, omega y equal to omega 2. So option A. So things to remember here is, one is how to find out the eigenfrequencies and how to convert this matrix form. This is the Lagrangian, this is the matrix form for kinetic energy and potential energy. Two masses of value m are moving towards each other with equal speeds of value 0.6 c. So here you have mass m moving with 0.6 c, and on the other side you have the same mass m, not the same mass, similar mass m moving with 0.6 c. Okay, they are colliding and they are sticking together and then moving. Okay, now what is the final mass m? Now let us see what is the mass of this m dash when it is moving with point c. So the mass m dash will be is equal to gamma times m, right? Now what is gamma? We don't know, but we are given v is equal to 0.6. Now write it in the form of fractions. So 6 by 10 is the value. Now write this, we have seen this shortcut how to find out gamma from v. So write it as 10, that is denominator as the hypotenuse, one side as the one side as 6, then the other side would be 8. Then gamma is nothing but hypotenuse divided by side 2. This is side 1, this is side 2. So side 2 hypotenuse is 10, side 2 is 8. So 5 by 4 is your gamma. So first mass m will increase by, so m dash is equal to 5 by 4 times m. Okay, similarly this is also moving with the same speed, so capital M would be is equal to 2 times gamma m. That is nothing but 2 into gamma is 5 by 4 into m. That is nothing but 10 divided by 4 m. That is nothing but 5m by 2. It would be definitely greater than 2 times the mass. So it will be definitely. So all values are greater. So you don't have any other option. In some questions, if you get some idea, if suppose these options were less than 2m, one of if these options, for example, if this was 3 by 4m and this is 7 by 8m, then even without looking into doing this problem, we can definitely write B, because when a body is moving, its mass is definitely greater than its rest mass. So together mass will be always greater than 2m. This is only one. Okay, so this is the actual method how to follow. Just follow the step by step, and this, please remember this trick how to get the value of gamma from V. Please don't use gamma equal to 1 divided by under root 1 minus v square by c square. You will keep doing this problem. It would take more than 2-3 minutes. Follow these simple methods, tricks to get into this answer. The charge Q is uniformly distributed in a sphere of radius r. The divergence of electric field inside the sphere. Now, what do you mean by divergence? Del dot A, where A is a vector. Now, since it is in 3 dimension, let us take r, theta and phi for our convenience. R, theta and phi. Okay. So our function is, or electric field is a function of r, theta and phi. Since it is radially varying and theta and phi are constant, our f is a function of r only. Now A is nothing but AR, that means radial component, plus theta component A theta into theta cap plus A phi into phi cap. So this is how you can represent a vector in 3-dimensional spherical polar coordinate. Now del dot A is nothing but 1 by r square sine theta dou by dou r square sine theta into AR, that means radial component, plus dou by dou theta r sine theta into A theta, that is the second one, theta component, and dou by dou phi of r into A phi, that is phi component. Now we have already said it depends only on r, so only this much we need to take, others are 0. So del dot A is nothing but 1 by r square sine theta dou by dou r square sine theta into AR. Now sine theta we can take it outside because it is taking derivative with respect to r. We are taking with respect to r, partial derivative. So sine theta it can come out. So del dot A is nothing but 1 by r square dou by dou r square into AR. That means radial component AR. Now, inside a spherical shell, or sorry, spherical sphere, inside the sphere, electric field is given by, electric field is KQR divided by capital R. So this is the formula for electric field inside the sphere. Then just substitute this value here. We want del dot E, that means 1 by r square dou by dou r of r square into k capital Q r divided by capital R cube. So this is equal to 1 by r square, k, q and r cube you can take it out, k, q and r cube taken out, r square and r cube, that is partial derivative of r with of r cube, that is nothing but 3r square. So this r square and r square get cancelled. What is remaining is 3kq by r cube, that is 3kq by r cube. This is del dot E. So your option A is B. Now one k is missing here. So what you have to remember from this question? What is del dot A in spherical polar coordinate and electric field inside? Electric field inside the spherical or sphere. Okay, now electric field inside is this much. What is electric field on? Electric field on the sphere, it is, just put small r equal to capital R, you will get kq by r square. Okay.